4 astronauts, 1 rocket, and weather that just will not cooperate. The Crew-12 team is in quarantine in Florida, watching the forecast and waiting.
A visitor from another solar system is heading for the exit and handing us a chemical blueprint of its home solar system on the way out. Plus, a rover on Mars just took orders from an AI instead of a human for the very first time.
All that, plus a rare solar eclipse just days away, new research that could change how we search for life, and Starship making a comeback after a dramatic setback. It's a big day. Welcome to Astronomy Daily.
Let's get started. Anna, take it away.
Hello and welcome to Astronomy Daily, your daily guide to what's happening out there. I'm Anna.
And I'm Avery. It is Wednesday, February 11th, 2026. We have 6 stories to get through today, and honestly, it's one of those lineups where every single one of them earns its place.
We're going to kick off with the ongoing Crew-12 drama at Cape Canaveral, then swing to deep space for the latest from 3i/Atlas. And then we've got a Mars AI story that genuinely made me stop and think. Some fascinating new science about why Earth ended up being habitable at all. A rare solar eclipse just days away, and a big Starship update.
Let's get into it.
So, Avery, as of this morning, the Crew-12 mission has now been pushed back to no earlier than Friday, February 13th. That is the 3rd attempted launch date in less than a week.
It really is. Weather has been the culprit each time. The teams originally had a window on Wednesday, 11th, today, but conditions along the Dragon spacecraft flight path just weren't cooperating, so they waved it off. Then Thursday the 12th got pushed. Now they're looking at Friday morning with a planned liftoff at 5:15 Eastern.
And the reason there's so much urgency here isn't just that people are impatient. The International Space Station is currently running on what NASA is calling a skeleton crew. Crew-11 had to come home early back in January, following a medical issue with one of the astronauts. And since then, the station has been significantly understaffed. Crew-12 is the relief team.
Which makes every weather delay feel a little more loaded than usual. The people up there are doing the work of a full crew with a much smaller team.
So who's making this trip? Well, let's run through them one more time. Commander is NASA astronaut Jessica Meyer, a veteran of a previous long-duration station mission, and well known for conducting the first all-female spacewalk back in 2019. She'll be joined by pilot Jack Hathaway, also from NASA, on his first spaceflight.
And then there are 2 mission specialists, Sophie Adnot from the European Space Agency, representing France, and Andrei Fedyaev from Russia's Roscosmos. This will be Fedyaev's 2nd trip to the station. Once they dock, they're looking at an 8 to 9 month stay, longer than usual to cover the time lost by Crew-11's early departure.
Now, there is a subplot to this mission that I think a lot of people may not have heard about. Back in December, Russia's Roscosmos quietly removed cosmonaut Oleg Artemyev from the Crew-12 mission. The official line was that he had transitioned to, quote, other work.
Which is the kind of statement that immediately makes you want to know what the actual reason is.
Right, and investigative outlet The Insider reported that Artemyev was effectively expelled from the United States by being accused of violating international traffic in arms regulations by allegedly photographing SpaceX engines, documents, and other sensitive technologies with his phone and then exporting that information.
So he was allegedly taking photos inside SpaceX facilities of proprietary rocket technology and sending it out of the country.
That appears to be the allegation. He was replaced by Andrei Fedyaev, and Roscosmos has said very little publicly. But it's a striking reminder that even in the cooperative world of the International Space Station, the geopolitical tensions of the wider world don't disappear at the door. And it raises interesting questions about what access international partners are given to commercial SpaceX facilities. These aren't NASA government sites.
Anyway, the crew are in quarantine, the rocket is on the pad, and all eyes are now on the Florida forecast for Friday. We'll update you the moment there's news.
Our second story takes us to the outer solar system, where Interstellar Comet 3I Atlas is continuing its farewell tour. And before it goes, it's been handing scientists some truly unexpected data.
Just to set the scene, 3I Atlas was discovered in July 2025 by a telescope in Chile, traveling far too fast on a trajectory that couldn't possibly have originated within our solar system. It's only the third interstellar object ever confirmed to have passed through, after Oumuamua in 2017 and Borisov in 2019.
NASA's SpaceX telescope observed 3I Atlas in December 2025, and the results have been remarkable. The comet's coma has become dramatically more active and chemically complex. SpaceX detected water ice, carbon dioxide, carbon monoxide, organic compounds, and rocky material being ejected in chunks far larger than the fine dust grains you'd normally expect. The scientists described it as a cocktail of chemicals that haven't been exposed to space for billions of years.
The James Webb Space Telescope added another layer, finding that the ratio of carbon dioxide to water in the coma is approximately 8:1, which is one of the highest CO2 to water ratios ever measured in any comet. In our solar system's comets, water tends to dominate. So the implication is 3I Atlas may have formed much further from its home star than a typical comet would, near a CO2 ice line. Its chemistry is essentially telling us something about the architecture of the planetary system it came from.
There's also data on the comet's spin. It rotates once every 16.16 hours, and researchers found it had strange, wobbling jets in a rare sun-facing anti-tail. Normally, comet tails point away from the sun, but 3I Atlas briefly had one pointing toward it. Genuinely weird behavior.
As of today, 3I Atlas is in the constellation Gemini, fading beyond naked eye visibility. It's heading towards a Jupiter flyby in mid-March before leaving the solar system forever. And there's one more data release to watch for. ESA's JUICE spacecraft observed 3I Atlas back in November, but couldn't transmit the data while using its antenna as a heat shield. That data is expected to arrive here on Earth any time now in February, so there could still be one more surprise coming.
When future generations ask what we learned about other solar systems in 2025 and 2026, 3I Atlas is going to be a big part of the answer.
Safe travels, 3I/Atlas. Don't be a stranger, although I suppose by definition you always will be.
Now, this next story is one I find genuinely fascinating because it sits right at the intersection of robotics, artificial intelligence, and the practical reality of exploring another planet. In December, NASA handed the wheel of the Perseverance Mars rover to an AI. Not metaphorically, literally. The AI generated the rover's driving waypoints, and the rover followed them without human control across 2 separate days, covering a total of 456 meters.
And just to be clear, this isn't NASA hopping on a bandwagon. They have been working on autonomous rover navigation for years out of sheer necessity. Mars is so far away that a round-trip radio signal takes around 25 minutes. That means every driving instruction you send has a built-in delay, and every unexpected obstacle requires another 25 minutes to respond to. Autonomous navigation isn't a luxury, it's a practical requirement.
So in this demonstration, the AI analyzed orbital images from the Mars Reconnaissance Orbiter's HiRISE camera, as well as digital elevation models. It identified hazards, sand traps, boulder fields, bedrock, rocky outcrops, and then generated a path defined by a series of waypoints to avoid them. From there, Perseverance's own onboard auto navigation system took over to actually execute the drive.
And importantly, before those AI-generated waypoints were sent to Mars, they were tested here on Earth using Perseverance's engineering twin, a full-scale physical replica at JPL's Mars Yard. So this wasn't a blind experiment. There was a safety net built in.
The AI in question is built on Anthropic's Claude, which regular listeners may know as the same AI that helps power this show. So there's a certain pleasing symmetry and reporting on that.
There really is, and the engineers are excited about what comes next. One of the current limitations is that the longer a rover drives without human relocalization, essentially humans checking in to confirm where it is on the map, the more positional uncertainty built up. Over 655 meters, that uncertainty can grow to around 33 meters. The goal is to use AI to solve that relocalization problem too, so rovers can handle kilometer-scale drives entirely on their own.
And beyond Mars, this matters for the whole future of deep space exploration. NASA's Dragonfly mission to Saturn's moon Titan will rely heavily on AI for autonomous navigation as it flies around in Titan's thick atmosphere. The further from Earth you go, the more critical autonomous systems become, because waiting 25 minutes for a signal is one thing, but waiting hours or days is quite another.
The vision the JPL team laid out is compelling. Intelligent systems not just at mission control here on Earth, but embedded in the rovers, helicopters, and drones themselves, trained on the collective knowledge of NASA's engineers and scientists. The Mars rover of 2035 may look quite different from Perseverance.
Our next story is one of those pieces of research that sounds almost philosophical at first, but turns out to have very concrete scientific implications. A new study published in Nature Astronomy has found that life on Earth may be thanks to an extraordinarily lucky chemical accident during our planet's formation, nearly 4.6 billion years ago.
And when they say lucky, they mean it. The research suggests that two elements absolutely essential for life as we know it, phosphorus and nitrogen, only stayed accessible on Earth's surface because of a very precise and apparently quite rare balance of oxygen during the planet's earliest formation.
Here's how it works. When a young rocky planet forms, it's initially molten, a churning ball of liquid rock. As heavy metals sink inward to form the core, lighter materials stay near the surface. During this chaotic stage, called core formation, the amount of oxygen present determines where other elements end up. The researchers from ETH Zurich found that oxygen levels need to fall within a surprisingly narrow range for both phosphorus and nitrogen to remain in the mantle and crust, available for future life.
Too little oxygen and phosphorus bonds with iron and gets dragged into the core, taking away a key ingredient for DNA, cell membranes, and energy transfer. Too much oxygen and nitrogen is more easily lost to space. Either way, the chemistry needed for life never fully comes together. Earth hit this sweet spot, what the researchers are calling a chemical Goldilocks zone, precisely.
The lead researcher, Craig Walton, put it clearly. If Earth had had just a little more or a little less oxygen during core formation, there would not have been enough phosphorus or nitrogen for the development of life. They also modeled Mars and found it likely had the wrong oxygen balance, more phosphorus in the mantle than Earth, but less nitrogen. Challenging conditions for life as we know it.
This is a significant challenge to how we've traditionally thought about the search for life. The habitable zone, the region around a star where liquid water can exist on the surface, has been our go-to framework. But this research suggests that even a planet in the perfect orbital position with liquid water could be fundamentally incapable of supporting life if its internal chemistry didn't form correctly.
And here's the hopeful flip side. The oxygen conditions during planetary formation are linked to the chemistry of the host star itself because planets form from the same material as their stars. So in principle, by looking at stellar chemistry, we might be able to predict which planetary systems had the right conditions from the start. Walton's advice for the search? Look for solar systems with stars that resemble our own sun.
It makes the Earth feel even more special, and the universe feel a little more vast and empty. All right, from the philosophical to the spectacular. In exactly 1 week's time, on February 17th, an annular solar eclipse is going to sweep across the southern hemisphere. This is the so-called Ring of Fire eclipse, where the moon passes directly in front of the sun. But because it's at a slightly greater distance from Earth than usual, it appears a little smaller than the sun's disk. The result is a thin, blazing ring of sunlight surrounding the moon's dark silhouette. Stunning.
Though this is different from a total solar eclipse, where the moon completely covers the sun and you get that eerie darkness in the middle of the day. In an annular eclipse, the moon blocks about 96% of the sun's disk, but that remaining sliver stays visible, and the ring effect is only visible for around 2 minutes and 20 seconds at any given location in the past.
The path of annularity for this one is quite remote. It runs primarily over Antarctica, which means the full Ring of Fire experience will be witnessed by the researchers at places like Concordia Station, the French-Italian outpost on the Dome Sea Plateau, and Mirny Station, the Russian base on the Davis Sea coast. We're talking about teams of maybe 50 to 200 people, a very exclusive audience for one of nature's best shows.
For the rest of us, partial phases will be visible from the southernmost parts of South America, southern Chile and Argentina, and from parts of South Africa. Not the full ring, but still a striking sight if you're in the right location with proper eclipse glasses. And it goes without saying, never look directly at the sun during an eclipse without approved eclipse glasses. The Ring of Fire does not mean the sun is safe to look at.
There's also something lovely about the timing of this eclipse. February 17th is the start of Chinese New Year, specifically the Year of the Fire Horse. The new moon that causes the eclipse is the same new moon that marks the beginning of the Lunar New Year, and the crescent moon visible on February 18th will signal the start of Ramadan. So this one celestial event sits right at the intersection of multiple major cultural moments around the world.
If you're not in the past and want to watch, there will almost certainly be live streams from research teams in Antarctica. We'll keep an eye out and link to any good ones in the show notes. And we're going to close out today's main stories with a Starship update, because after a frustrating lull, things are very much moving again at SpaceX's Starbase facility in South Texas.
To understand why this is significant, you need a quick bit of context. The last Starship flight, Flight 11, was the final launch of the Block 2 configuration. SpaceX is now transitioning to Block 3, which is a significantly upgraded architecture featuring new Raptor 3 engines, enhanced performance, and improved reusability features. But the development of Block 3 hit a serious setback when Booster 18, the first Block 3 booster, failed during cryogenic pressure testing late last year. Its outer container cracked.
SpaceX moved fast. Booster 19, the replacement, was stacked and delivered to the test site in record time. And in the first week of February, it successfully completed not one, but 2 cryogenic pressure tests. The first was on February 2nd, the second on the 4th. Both passed. Starbase watchers described it as looking like the entire booster had frozen solid as super chilled liquid oxygen entered it, which is exactly what it's supposed to do.
Booster 19 has since been returned to the production site for further work, and all eyes are now on the flight stack, Booster 19 paired with Ship 39, which is being prepared for what will be the debut of the full Block 3 vehicle. The current target is a launch window in the February to March timeframe, though sources familiar with the program point to March as the most realistic date.
Flight 12 is a genuinely significant milestone. It'll be the first flight of the Block 3 Starship, the first use of the new Pad 2 architecture at Starbase, and the debut of Raptor 3 engines at scale. The stakes are high. NASA needs a successful Block 3 to progress towards using Starship as the human landing system for the Artemis program's crewed lunar missions. That timeline is already under pressure.
Meanwhile, infrastructure work continues at a remarkable pace. Pad 1 at Starbase is being rebuilt. SpaceX's facility at Kennedy Space Center at Launch Complex 39A is progressing toward a first Florida Starship launch in the second half of 2026. And environmental approval has been granted for a brand new Starship complex at Space Launch Complex 37 at Cape Canaveral, which would eventually give the program 5 launch pads across Texas and Florida.
5 launch pads for Starship. It's a lot to take in, but after Booster 18's failure and the testing lull, the fact that Booster 19 has passed its cryo tests and Flight 12 is back on track is genuinely good news for the program.
We will be watching closely.
That is everything we've got for you today on Astronomy Daily. Fixed stories, all of them worth your time, from astronauts waiting for weather in Florida to a comet carrying 4 billion-year-old secrets from another star, a rover taking orders from an AI on Mars, new science that makes life on Earth feel like a cosmic lottery win, a ring of fire 1 week away, and Starship dusting itself off for another attempt at history.
A genuinely brilliant day to be following space news. Thank you so much for spending part of it with us.
If you enjoyed today's episode, please subscribe wherever you get your podcasts. And if you want to go deeper on any of these stories, full show notes and our blog are over at astronomydaily.io.
Until tomorrow, keep looking up.
Take care, everyone.